So my name is Risto Öörni. I work as a senior advisor with the Finnish Transport and Communications Agency Traficom, and the aim of my presentation is just to give a short overview of the IP-based communication profiles developed by the C-Roads platform. So next slide, please. So first, everything started with the need to share CITS messages over IP-based networks, and when the profiles were developed, a number of requirements were identified, and these are of course related to quality of service and the changing network topology and the need to discover messages in different places, and also security, including confidentiality, integrity, and availability. And so far, C-Roads has defined basically 3 IP-based communication profiles. So first, we have the basic interface, that is the data plane of the information exchange. Then we have the improved interface that operates between the interchange nodes and is also the control plane. Then we have transport layer security between the CITS actors and interchange nodes exchanging information, and this provides authentication of the nodes and encryption of communications between them. Next. So then we can go to the scope of IP-based communication. So in this figure you can see 4 entities: the end user entity, and there are two serving backside entities, and also the roadside infrastructure. And the IP-based communication deals with communication between the backend systems. And then of course we are also planning to introduce recommendations for the communication between the user and the backend, but this is usually vendor specific. And of course the road operator is allowed to select the interface it wants to use between its backend system and the roadside infrastructure. So basically the IP-based communication profiles are applicable to communication between backend systems. Next, please. So and the IP-based profiles, they support both centralized and decentralized exchange of information. So first we have the basic interface that can be used for peer-to-peer connections between the CITS actors, and then we have the improved interface that provides the control plane, for example the capability to discover messages not only from actors connected to the same interchange node, but also CITS actors connected to different interchange node. And this is the key functionality. And everything works with the publish subscribe model. So once the source is discovered, the CITS actor is able to subscribe to messages. Next, please. So then we can go to the details of the basic interface. So the basic interface operates between 2 CITS actors, and it provides the message delivery using the publish subscribe model, and the delivery of messages is implemented with AMQP. And of course the message subscription is based on the message type, the geographic location, and also other variables may be used to filter the messages. And in the current situation, the security of the connection is based on bilateral agreement between the nodes. Next, please. So then there are more details about the basic interface. So on this figure you can see the packet structure, and when you look at the figure you can see that the innermost structure is the ETSI CITS message. Then we have the ETSI security envelope and geonetworking headers. But then what is not contained in those is the field that is used for for filtering messages. So this is what we call end-to-end application properties field, and this is the field that is used by AMQP, and of course the outer structure is TLS because the messages are transmitted over TLS. So we have the TLS header and optionally also the message authentication codes. Next, please. So then we can go to the improved interface. So while the basic interface provides the data exchange and the data plane, the improved interface is the control plane functionality, and it operates between the CITS interchange nodes, and first it allows the interchange nodes to discover other interchange nodes, and at first the interchange node, it connects to a dedicated DNS to find the other interchange nodes, and then it establishes a control channel with the node with whom it prefers to exchange information, and then once the control channel has been opened, then the interchange node requests the capabilities of the other interchange node, and then the other node responds with the capabilities it has, and finally the interchange node sends a subscription request, and the other interchange node responds with the endpoints where data can be retrieved. And then it will be possible to exchange information using the basic interface. Next, please. And on this slide, you can see another illustration of the functionality of the improved interface. So how first there is the discovery of interchange nodes, then there is the request for capabilities and answer, and then there is subscription request, and then response with the endpoints, and finally a possibility to exchange information. And the filtering of the messages, it may be based, as already explained in the previous presentations, it may be based on geographic area or message type or other characteristics. Next, please. And finally, I will go to the deployment documentation. So as you already know, the IP-based interchange profile document is just one part of the whole deployment documentation for CITS developed by the C-Roads platform. And when you use the document, it should be understood in the context of the whole C-Roads documentation that is available in the releases. And now I think it's time to finish the overview. And if you have any questions or comments, please raise your hand.